All right. Good morning, everyone. I'm happy to be here today. I work at Marshall Space Flight Center in Huntsville, Alabama. I want to thank Miss Mary Pate for reaching out and inviting me to this opportunity, as well as Kaylin Mickles of Marshall Space Flight Center's group, who helps coordinate our outreach opportunities. And I uh, want to thank Mr. Phil Teague for introducing me as well.
It's actually Rowena. I'm incognito.
Oh, sorry. And of course, I thank you for the introduction, and it was great. And I had an overview here. I hope you all can see all of the pictures and everything on the slide. It's a picture of me sitting by a turbo machinery of combustion components, as well as by a poster that I've designed for a conference at Goddard in 2018. And Goddard Space Flight Center is located in Greenbelt, Maryland. And there's a picture of me welding on a rotation. I was doing some MIG welding there. And I had just gotten hired on full time. I was in a professional internship program. And as he mentioned, I was a co-op student. I went to the propulsion group for detailed design, where I did computer aided drafting or CAD modeling. I rotated to friction stir welding, which was a newer type of welding. It's only about 30 years old. I'd done structural analysis or finite element analysis, where we tried to see how much load a component could take prior to deformation or even breaking. The system definition and integration group was the start of my systems engineering career. I did interfaces between the ground systems and the rocket. Then I got a promotion to the HLS group, or Human Landing System. And so I stopped working on the Space Launch System, or SLS, and went to HLS and started doing risk reduction integration work. Then NASA received we received a new contract working with 5 different contractors around the US. And so I became a technical manager for one of them. And that's my current job right now. So I have a short video about what does NASA do. And this is about a little over 2 minutes long or so. So hopefully you all enjoy it. Let's see, I think I just received something in the chat saying that there's no sound on the video. This one just has some music, if you heard anything. I'm not sure if you all can hear the music on here. Let's see.
No, there's no sound.
Oh, okay. Because like I can hear the music in the background. Not sure why it's not any sound on the video though.
Well, if it's just music, that's okay.
That's okay. Yes, I think one of them that someone will be talking though. but I may can talk you through that one. But I'll go ahead and continue with the video. Hmm. Okay, so overview of, hopefully you all were able to see everything that we do, or at least most of what we do at NASA. So we have quite a few projects that we're working on. And so some of you may ask, why go to the moon? Why go to space, period? And there's a lots of spinoffs that has come from going to space. And but basically, those are these are the things that are explain why NASA's technologies are important. Like for instance, a vacuum cleaner or a dust buster, the little handheld vacuum cleaner, because we wanted to collect soil samples from the moon. That's why it was invented. So we're trying to help improve life here on Earth. And we've had more than 2,000 spinoffs since 1976. And I have some examples, like your sunglasses that came from the astronauts' helmets. So that's why they rarely ever get scratched. The air purifiers, obviously we're trying to have clean air in space as well, since we don't know what's all out there. So that was a spinoff. Another one would be the memory foam that you were having, maybe your mattress or pillow. And of course, then there's another one we all know of as the cell phone and any other wireless communications. I mean, even Zoom is a spinoff from space, because we had to be able to communicate to and from the astronauts thousands of miles away. And of course, the GPS, or the navigational system, is also a spinoff. And to learn more about spinoffs, you all can click the link, and I will definitely share this presentation afterwards. We'll probably share it on the Google Drive and give you all access to it. So this next slide tells you where all of NASA's locations. So NASA has about 10 locations all over the US, as you all can see. There are more than 10. There are some facilities like White Sands Test Facility, which is in New Mexico, that's also run out of Johnson Space Center in Houston. We have the Michoud Assembly Facility, which we call MAP for short, which is run out of Huntsville, Alabama, or the Marshall Space Flight Center. We have the Katherine Johnson IB&B facility that's run out of Goddard. It's located in West Virginia. We've renamed our headquarters to Mary Jackson headquarters after the Hidden Figures. And so we have each one of these centers have a specialization that they do. For example, Glenn Research Center in Cleveland, Ohio specializes in electric propulsion. Marshall Space Flight Center specializes in liquid and solid propulsion. Michoud is where we build most, if not all, of our large spacecraft. That's where most of SLS was built at. Stennis Space Center is where we've done all of our engine testing. Of course, our headquarters is in Washington, D.C. We launched from Cape Canaveral and at Kennedy Space Center. We do a lot of our aeronautics work at Hampton, or Langley Research Center, which is located in Hampton, Virginia. And over here in California, we do lots of design work and work with Mars at the Jet Propulsion Lab, or JPL. We have Ames Research Center, and there's lots of mostly avionics and data research that goes on here. We have Armstrong Flight Research Center, and of course the astronauts train at Johnson Space Center. So we have space centers all over the US, and Goddard specializes in telecommunications and our large satellites and telescopes. This video right here tells you about the NASA overview. I'll try to talk you all through it. This tells think they'll first start off about, this is during the Apollo era and the shuttle era that you're seeing. And of course, all of these videos are on YouTube, so you all can hear the sound. And these are some computerized images of on the moon, and these are people who are trying to do research on SLS and living in space. And you can see it. These are the different NASA centers, such as Marshall, Johnson, and Glenn. And this is at Stennis Space Center in Mississippi. Right, this was some footage from Apollo era, and now this just tells you a little bit about SLS. That was some of our trajectories from the Earth to the moon. Right, so this was footage from the 60s during the Apollo era until today during the SLS or Artemis era. So I wanted to highlight our careers at NASA. Contrary to what people may think, we do not just hire astronauts, engineers, and scientists. We also hire people of many other backgrounds, such as business and communication. We have accountants, we have budget analysts who keeps up with our money. We have procurement who purchases our goods and deals with our contracts. We have human resources, hiring and training of personnel. We even have folks who interface with the public and communicates with the media, our public affairs specialists. We even have attorneys, believe it or not. Most of them are patent attorneys. And we also just have some that interprets general law as it relates to the workforce. Some deals with contracts and acquisition integrity program. And they just help with all of our legal policy. So we have several types of legal practice groups. And of course, these attorneys, they interface with just about everybody, from the field center to the administrator who's located at our headquarters. And they deal with lots of issues that goes on with the agency, as well as the patents themselves. So of course, I talked about scientists and engineers. We hire all disciplines. Most of our engineers at NASA have aerospace, electrical, or mechanical engineering degrees, but we do have some chemical, industrial, materials, and civil engineers. As far as the sciences, we have a lot of people here with physics and mathematics degrees. We also have a lot of chemists and biologists. And we do have some who went to trade school, so maybe they do welding or machining. Those are technicians. So we're a multidisciplinary agency, believe it or not. So we have lots of disciplines, different degrees. Most of the folks who work at NASA, they work either in ground ops. These are the disciplines that most of them work in, or avionics, whether it's propulsion, which is our engines group. They do flight ops, ground ops. Yeah, we have mission control, guidance, navigation, and control. We have systems engineering. We have different types of analysts, whether it's fluid, structural, or dynamics analysis, or even thermal analysts. We have folks who work in our health and medical group, even in our natural and induced environments. We even have materials engineers here too as well. And of course, avionics and software. So over here on the right shows different pictures of our work. You see the engines on the left-hand side, and we see a couple of analysis going on and see some pictures of mission control. So I'm going to introduce to you all our major project, the one that everybody's looking forward to seeing launch sometime this summer. It's called a Space Launch System, or SLS. This picture on the right is the SLS on the mobile launcher. It's rolled from the Vehicle Assembly Building, or the VAB, to our launch pad on March 17th. You've all probably seen it in the news. I know they had to do some couple of wet dress rehearsals. That's when they fill the rocket up with all these fluids and propellants and see how it reacts to it. And I know it has to go back to the VAB for additional testing, probably like the flight termination system. And of course, the first woman and the next man will land on the moon in this vehicle. And this is the largest rocket that's ever built in the US. This rocket will also contain several small satellites about the size of an average shoebox. We call those secondary payloads, and they're located like in the upper middle part of the rocket, just beneath the launch vehicle stage adapter. You can find out more about the SLS if you go to this website or this link that I have in the presentation. Our next major project is the Mars Ascent Vehicle, or MAV, as we call it. It came from the NASA's Perseverance rover, which launched in August of 2020. It arrived at Mars in February of 2021. It was a really big deal that day when it launched and when it arrived. Everybody was watching it. So that's Perseverance rover. It's about the size of a Toyota Corolla. It roams all over the surface of Mars, collecting soil and rock samples and possibly water samples if we do find that. And what it does, it stores it. And then you have this Mars Ascent Vehicle, or MAV, that will be on the Martian planet, and will be able to launch it from Mars to Earth. And it is the first of its kind to do so. And these two pictures are the artist's rendering of it. And I have another video that tells you a little bit more about it. But since our sound isn't working, I will send out this presentation and let you all watch it at your leisure. Let's see, and it's about 3 minutes or so long too. And this next picture is the Gateway. This is the new space station. It's similar to ISS, or International Space Station. And this is where the Orion, which is the little vehicle you see on your left-hand side, will dock to it. It will have astronauts on it, maybe about 2 to 4 astronauts. And this space station will revolve around the moon. And of course, we're partnering with commercial and international partners to build this gateway. And when I say commercial partners, I'm talking about companies like Boeing and SpaceX and Northrop Grumman. And as far as the international partners, it would be the Canadian Space Agency, or CSA, the European Space Agency, or ESA, and of course, Japanese Space Agency, or JAXA. And of course, we're trying to get this no earlier than 2024. And of course, there's more information you can find out at nasas.gov, or the Gateway Overview. Next is the project that I've been working for the past 2 years, Human Landing System, or HLS. In April of 2020, our agency announced that we would have a competition between 3 teams, which are you can see their rovers or their landers right here. And we would choose one for the initial landing system, or that we call option A. The one that was selected is the one on the far left. This is SpaceX design. The one in the middle is Dynetics, and the one on the right is a collaboration between Blue Origin, Northrop Grumman, Draper, Lockheed Martin for Rover. And currently we've just announced another proposal, and this one will be for the sustaining phase of the mission. So we'll have different companies put in a request or put in a proposal to hopefully get a contract from NASA to build its next rover, its next lander. And this video talks about life inside of the International Space Station. It's about 2 minutes long, too. So I'm sure you all are curious to see how's life inside of the space station. And this is the sleep station that that lady is talking about. She has a sleeping bag in here. It's like a little phone booth. It could also be an office. This is the exercise room or node area. And of course, astronauts are required to exercise on board the International Space Station. This is their kitchen or galley where they keep the food stored. Of course, their food is stored like in little packages. This is just where they keep the spacesuit for when they go and do their extravehicular activities or EVA. And that's like their sunglasses that I was telling you about, the NASA spinoff that she was talking about. This is the restroom. And of course, the number 1 and number 2 as far as using the restroom. And she's telling you about the tissues that they have in the space station. And of course, disinfectant wipes. And when you get homesick and you want to just get a pretty view of the Earth, you would go to this node. So this is pretty much life inside of the International Space Station in a nutshell. Right, so as you all see, they pretty much float from room to room. And this concludes my presentation, and I encourage you all to follow NASA on social media. We're on all forms of social media, and to visit our website at nasa.gov. See, does anyone have any questions or comments for me? I appreciate you all's time.
It looked like there was a lot of wind and her hair was flying. What causes the wind within the spaceship?
Actually, it could be outside air that's contributing to it. Like if there's like maybe a tiny hole or a leak somewhere, but inside of the International Space Station, there is no gravity. So it just feels like they're floating all the time. So that's why they kind of like float from room to room. And that's why, like, if she doesn't put her hair in a ponytail, it will probably just float all over the place. It's like a 0G type thing.
Thank you.
You're welcome.
Very interesting.
Here's a question. Why do the astronauts wear orange suits?
Those orange suits are for the IVA or the intravehicular activities. And I'm thinking it's probably like, I know they're the only ones out there, so it's not, they can't wear it for the same reason that a hunter would wear it, like the orange vest while hunting, just in case other hunters are out there and they can see them. I'm not for sure exactly why they chose the color orange. And I know they have to get another color besides white, since that's the extravehicular activity ones, and those are usually the more bulky suits that you have. But I think it's probably just to tell the main difference between intravehicular activity and the extravehicular activity.
Is this so they don't put on the wrong suit to do the wrong thing?
Correct.
Any more questions? I am totally fascinated.
What,
Okay,
I have a question, What is the
sure.
what is the ratio of men and women in the NASA program that you're in?
Not for sure the exact numbers, but I do know there's definitely a lot more men than women. We have been increasing over the past several years. I know probably in the 60s, it could have been maybe like 20-1, but I'm sure that number is probably like maybe 10-1 or something around that range now. But yes, definitely a lot more women than it's ever been, especially in the engineering program. I mean, most of our women tend to work on the business side, but thankfully there are some that are coming more into the engineering and the sciences.
Well, you're very good representation. Thank you.
Thank you.
Any more questions? Well, Leslie, thank you very much for making this presentation for us.
You're welcome.
We have, hopefully in the near future, when things are less stressed out because of COVID, we could perhaps take a visit to Huntsville and have a tour of NASA. Is that a
Yes, that would be
possibility?
great. Yeah, definitely will look, definitely let me know, and I don't mind giving you all a tour. And definitely looking forward to that.
Okay, great. All right, if there are no more questions, then we will end it for today. Thank you.
All right, thanks everyone.